graphing quadratic equations. In this video, we are going to do another example of figuring all the important details about the quadratic equation and then analyze things beyond that. But not only that, we're going to figure out how do we work this equation if it's not given in the vertex form right away. So let us see our example. This one is f of x equals 3x squared plus 12x plus 5. So this is clearly not in our vertex form where we can just pick out our h and k values right away. The way that we get it from this first equation into our vertex form equation is by completing the square. Okay, typically our first step in completing the square is we want to move our 5 to the other side of the equation. But we have a problem here. This is not actually an equation where it's equal to another number. Okay? It's no longer an equation, it's a function. It's in function form. So I cannot move that 5 to the other side. So I'm kind of just going to separate it from the rest of the group. The other problem is that I need to get rid of this 3 somehow. And normally I divide both sides of my equation by it. But I cannot do that because, again, I do not have the other side of the equation. So what I need to do with that 3 is I need to factor it out. But I'm only going to factor it out from my first 2 pieces because, remember, this constant should really be on its own on a different place. So taking my 3 out of the parentheses leaves me with 3 times x squared plus 4x. Now I'm going to go ahead and put in my blanks here because I know I have to add in something special to complete the square. Now I'm going to put my 5 here, and I need to put in my second blank to counteract my first blank. Now in those blanks, we know that we take our b, or our new b, divided by 2 squared. Well, our new b is 4, and when I divide it by 2 and square it, that gives me 2 squared, which gives me 4. So I'm actually going to add 4 in this blank. Okay, so I need to figure out what goes into my second blank. Now normally we would just automatically put that 4 in there and it would count and it would balance each other out. Now I cannot do that here because of 2 reasons. The first one is because it's on the same side of the equation. So if I were to add these 2 together, they would actually do that. They would add, not cancel. So I need to do an opposite sign here. The second reason that I cannot just put a 4, or even in this case a negative 4 in there, is because I have this 3 to worry about. So if I were to multiply all this out, on the left I would have 3 times 4, which gives me positive 12. So here I need something to cancel that out. So I need to multiply this by a 3 as well. So on the left, when I add a 12, that's going to cancel out with my right when I subtract a 12. Now I have this set up perfectly to complete the square with and to give me my vertex from here. So my function is going to read 3 times, now I factor this parentheses, it's going to factor as something squared, so x plus 2 quantity squared. And on the right, I have 5 minus 12, which gives me negative 7. Once I compare that with my generic vertex formula, that's going to give me my most important thing about the graph. So in part B, I want to know, does this parabola open up or down? Well, that comes from my a value. In this case, my a is positive. That tells us that our graph opens upward. So my answer is it opens up, which tells me that I'm going to have a U. The vertex. The vertex is going to come from HK. So my H value is something to do with this too. But remember that these signs do not line up. So your h value is going to be the opposite sign. So your h value is going to be negative 2. Now your k value. Your k value is going to be negative 7. And it's going to be negative because your signs do not line up. So your k value is negative 7. So that gives us our vertex, and that tells us that our graph opens up. Our most important two details about this graph. Now, completing the square is actually the complicated way to get the vertex, especially since this completing the square process is a little bit different than the completing the square process that I've taught you before. So, the easier way to come up with the vertex is by using the formula. And it is negative b over 2a, that's your x-coordinate or your h value. And then what you need to do with that negative b over 2a is you need to plug it in for your function to come up with your k value of your vertex. Now, there's an easy way to remember this. This negative b over 2a, it actually comes from your quadratic formula. So, if you were to write down your quadratic formula, and if you don't remember it, maybe you need to sing it, Pop Goes the Weasel. Okay. So I have my quadratic formula. If you cross out the plus or minus and the square root, whatever you're left with, that gives you your vertex formula. So the first coordinate of your vertex formula comes from that there, negative b over 2a. So let's do it with this example. And notice this is the same example that I just showed you before. My negative b over 2a. So my negative, my b value is 12 over 2 times my a value of 3. Gives me negative 12 divided by 6, which gives me negative 2. And notice that's the exact same coordinate that I got back here, my negative 2. Okay. Now this is an ordered pair. This is a point. So we need to come up with a second coordinate. The way that you do that is you just take this negative 2 and you plug it back into your function. So f of negative b over 2a is f of negative 2. You just plug it back in. So this is 3 times negative 2 squared plus 12 times negative 2 plus 5. Negative 2 squared gives me 4. 4 times 3 gives me 12. 12 times negative 2 gives me negative 24. And added to 5. 12 minus 24 gives me negative 12. And negative 12 plus 5 gives me negative 7. So my second coordinate is negative 7. So my vertex in this problem is negative 2, negative 7. Now, to figure out whether this graph opens up or down, it's the same idea that we had before. It's just not in the same format. If your leading term, if your a value is positive, then this graph will open up. So this opens up, and which gives us the U or the cup shape. Now, notice that the formula or the vertex that we got here gives us the same formula or vertex that we get here. So it doesn't matter which way you do it, but let me just tell you that completing the square is the hard way, and the formula is the easy way. So now that we know what our vertex and what direction our graph opens, let's come up with some other details about this graph. So the other details that we need to come up with is the y-intercept and the x-intercept. Our y-intercept we find by plugging in 0, or letting our x value be 0. So f of 0 gives us 3 times 0 squared plus 12 times 0 plus 5. Well, almost everything cancels out, and that just leaves us with 5. That tells us the ordered pair of our y-intercept of this graph is 0, 5. Our x-intercept, we do that by letting our y value or setting our whole equation equal to 0. So I have 0 is equal to 3x squared plus 12x plus 5. This is a quadratic equation. We can solve it one of many methods. My first instinct would be to factor this, but unfortunately this does not factor. So we have to solve this one by either doing the quadratic formula or completing the square. I'm going to choose to use the quadratic formula. So I have x equal my negative b value of 12 plus or minus square root of b squared. 12 squared is 144 minus 4 times a times c, which gives me 4 times 3 times 5, or 60. And that's all over 2 times a, 2 times 3, which gives me 6. So 144 minus 60, and my square root gives me 84. And I want to see if my square root of 84 simplifies using my good pi and my bad pi method, and it does. I can divide it by the largest square, which is 4. So that simplifies to give me 2 roots of 21. So that tells me that x is equal to negative 12 plus or minus 2 root 21 over 6. I want to divide all of my whole numbers by 2. And so that tells me x is equal to negative 2 plus or minus 1/3 times square root of 21. Now this is my most simplified exact answer. So officially my x-intercepts are negative 2 plus root 21 over 3, comma 0, and negative 2 minus root 21 over 3, comma 0. But if I want to figure out how these graph, I do not know what negative 2 plus root 21 over 3 is. So to graph these, I need to come up with my decimal approximation, meaning I just need to type these in my calculator. Okay, so the first one, negative 2 plus the square root of 21 divided by 3. And that gives me the decimal approximation of negative 0.47 and 0. My other one. I'm going to pull up the last entry that I did last time. If I hit second and then my enter, it pulls up the last entry that I used before. The only thing I need to change is I need to change that plus into a minus. So I typed in negative 2 minus root 21 over 3, and that gives me negative 3.53. which gives me my other approximation. So even though these are my exact ones, those were the ones that you would enter in when your computer program asked for it, these are the ones that you're going to use to actually graph, because we need to figure out where in the world those would actually graph. Okay. So we need to graph this function using that information that we found in parts A through E, and then we need to analyze it with the axis of symmetry, max or min value, and domain and range. So first let me start with my vertex of negative 2, negative 7. I have a y-intercept of 0, 5. I have two x-intercepts, one at negative 0.47, so about 1/2, and one at negative 3.53. And note that this parabola opens up, so he's going to look like this. So my u is something like that there. My axis of symmetry is the vertical line that runs through my vertex, because if I fold it on that vertical line, it matches on both sides. Remember, the equation of a vertical line is x equals, and then your x value of your vertex, which is negative 2. Max or min. This graph has a low point, which means I have a minimum. And that low point on my graph is the y value of your vertex. So this is a minimum at negative 7. Your domain is all of your possible x values. Well, this graph will go forever to the left and forever to the right. So your domain is negative infinity to positive infinity. Your range is all of your possible y values. The lowest y value on this graph we found in part H, which was negative 7. And this graph goes forever in the up direction. So the highest part of this graph is infinity. Infinity is, of course, a parenthesis, and negative 7 is a bracket, because negative 7 is a point on our graph. So that gives us our domain and our range. So this is where I'm going to stop this video. I have one more video of a third example that kind of goes over the formula for the vertex one more time, and it shows you something interesting that can happen with your x-intercept.